Hi, it's Mrs. Moret here with some help on today's lesson. So it's Unit 4, Lesson 3, and we had 3 learning targets for today. So to describe the connections between a statement in function notation and then the graph of the function. Use function notation to efficiently present a relationship between two quantities in a situation, and then use statements and function notation to sketch a graph of a function. We're going to focus on the first 2 learning targets to go over this today. And so looking at, this was the warm-up, it says that this is a graph of function f, which gives the height of a drone in meters t seconds after it leaves the ground. So you can see from the graph that the input is time and the output is the height. All right, and then when we think about the how that works, then this would be each of these heights would be represented by f of t. So f of t is equal to the height of the drone. Okay, so if we have to decide which value is greater, f of 0 or f of 4. So when time is 0, looks like the drone is still on the ground. And when time is 4, the drone is up here. So I would say f of 4 is greater. Okay, on the next one, which is greater, f of 2 or f of 5. And when I look at the graph again, f of 2 is going to be up here, and f of 5 is also up here. So I would say that they're the same. They are at the same height. And then f of 3 or 7, well, f of 3 is again up there at the top. So f of 3 is about right here. F of 7, the drone has landed. So f of 3 is a greater value. And then the last one is f of t or f of t plus 1. Well, that one depends on what t is. So if we said for t is 1, we'd be comparing this point where t is 1, and then t plus 1 would be this point here. But then, so in this example, f of t plus 1 would be greater. But then if we said, oh, well, what if t is 6? Well, t is time of 6, f of 6 is up here, and then t plus 1 would be 7, f of 7 is down here. Then f of t is the one that's greater. So for the last one, it just depends on what t is. It's not a general rule since it increases in the first part, and then it stays steady in the second part, and then it decreases in the third part. So it depends on what t is. All right. So then we moved into a story problem about smartphones. And what's important to note in this story problem is that the function represents the number of people. So it's the number of people in millions who own a smartphone years after 2000. So after year 2000. So P of 17, that means the year 2017, okay? So what does each equation tell us about smartphone ownership? So P of 17 literally means in 2017. And then if it's equal to 2,320, that's the number of people in millions who own a smartphone. So it's not 2,320 people, It's 2,320 million people. So 2,320 million. You could figure out what that is. It's like 2,320,000,000 people, but 2,320 million people own a smartphone. And then for the second part of the question, P of -10, well, -10 would be 10 years before the year 2000. So that means in 1990, actually the year I graduated from high school, and I can totally confirm that 0 people had a smartphone in 1990. They weren't invented yet. 0 people owned a smartphone. All right, so like I said, the second part of the lesson was like interpreting using function notation. Now we're going to go the other way and represent a statement using function notation. So we still have the number of people is in millions, and the time is the years after year 2000. So in 2010, so for 2010, then we would say F of 10, right? F of 10, because 2010 is 10 years after 2000. The number of people who owned a smartphone was 296,600,000. So that would be 296 million. And since we want the people in millions, then we would just use a 0.6 for the 600,000. And that's how we'd represent that. And then in 2015, about 1.86 billion people owned a smartphone. So for 2015, that would be F of 15. And it's equal to 1.86 billion. So 1.86 billion is 1,860,000,000. And so if we're going to give our number in millions, then it's 1,860. Okay, because again, the output is represented in millions of people. And just a really quick note is that I realized I started using F and we were supposed to use P to name this function. And so I'm just gonna fix that. So it was P of 10 and P of 15, but still you can see where those input values come from because it's years after the year 2000. So 2010 is 10 years after, and 2015 is 15 years after the year 2000. The last thing that we did was to kind of understand what these comparison statements mean. So we have some like function notation, what does the value mean? And then some inequalities, what does that mean? So the function W gives the temperature in degrees Fahrenheit of a pot of water on a stove T minutes after the stove is turned on. So we're looking at examples of W of T. Okay, so T is the input. It represents the time, T minutes after the stove is turned on. So T is the input, and then the output is the water temperature. Okay, so if we have W of 0 equals 72, that means time is 0. So the 0 represents time. So then what that means is that 72 degrees is the starting temperature of the water. So 72 degrees is the starting temperature of the water. All right, the next statement, W of 5 is greater than W of 2. That means that the temperature was greater after 5 minutes than it was at 2 minutes. Okay, so W of 5, the temperature after 5 minutes, is greater than W of 2, the temperature after 2 minutes. The next one, W of 10 equals 212. That means after 10 minutes, the water is 212 degrees. Okay, the next one, W of 15 is greater than W of 30. So that means at 15 minutes, the water temperature is greater than after 30 minutes. So at some point, the stove must have been turned off and it has started to cool, right? So for W of 15, after 15 minutes, actually, I'm going to rewrite that. And I'm going to say the temperature at 15 minutes is greater than the temperature at 30 minutes. Okay, so W of 15, the temperature at 15 minutes, is greater than W of 30, the temperature at 30 minutes. And I'm not going to write out the last one. It's very similar. W of 0 means the temperature after 0 minutes, so the starting temperature is less than W of 30, the temperature after 30 minutes. So the starting temperature is less than the temperature after 30 minutes. And that is a wrap up of today's lesson. I hope that was helpful.